Okay. Today's topic is material selection, right? Last 2 days we are seeing about types of composite and introduction of composite. So today we are going to see. Hello. Hello. Can you hear me? My screen is visible.
Yes,
Yeah.
sir,
Okay.
your
No
screen is
problem.
visible.
Yeah. No problem.
Okay, sir.
Okay. So basically, selection of material is affected by many criteria that you know, because we seeing about many criteria like price, amount, and quality of material. It's a basic need of customers, but the point of engineers, we are think about the properties of materials also. We are think about properties, mechanical, thermal properties. We think about the main criteria of material. Today we see about the selection of material and method of selection of materials also. So today we are seeing about some methods of selection. Some scientists derive the form of some standards for material selection. So every citizen want to using air connectivity. Hello. Hello. Okay. Every citizen want to using air connectivity. So reduction of aircraft price mainly based on the material. So every scientist and engineer have a main priority for reduction of rate of flight, and that's cost of a production of aircraft. So during material selection for aerospace application, some important factors should be considered. This factors should be considered, like ambient lower and high temperature. What is ambient temperature? Ambient temperature is a air temperature of a normal room. So lower temperature, high temperature. Humidity and different type of mechanical loading like tension, compression, flexural, fatigue, creep, and torsion. So what is humidity? Humidity means amount of water vapor in the air. So water vaporization is easily start to the chemical reaction of material in the corrosion level. So water vaporization is a major factor of material selection. If we are using the material in a highly water vaporized altitude, like high altitude flight is easily affected in water vapor. So we can definitely think about this main criteria. And different type of mechanical loading like tensions, compression, flexural, fatigue, creep, and torsion. So you know about that. As usual, you already know about the tension load, compression load, and flexural load. Fatigue is the starting propagation of a crack. So it was very important. In case the fatigue is formed and it's go to the crack portion, it's easily failure the material. So next one, the selection of material for aerostructure is too complex. So in normal mechanical part designs are easy compared to aerostructure manufacturing, because a mechanical part design comparison mainly focus on their strength, It's not based on any weight ratio. It's mainly focused on strength and durability. But aerostructures is too complex because it's need to durability and low weight in the high strength compared to some mechanical parts because of the variables involved. The variable criteria are involved, so it's too complex. In aerospace, strength and lightness are both important. In aerospace, strength and lightness are both important. Selection of materials should provide higher ultimate strength, yield stress, stiffness, temperature limits, corrosion resistance, fatigue resistance, fracture toughness, fragility at low temperatures, crack growth resistance, ductility, maintainability, and reliability. So in the material, some material have some properties, but aerostructures have a whole important positive properties are available in the some material. So we need to see about this type of criteria like stress, yield stress, stiffness, fatigue resistance, and crack growth resistance. Ductility is very important. So in early days, we are using wood, steel, aluminum alloy, titanium alloy, and fiber reinforced composites used to construct aerostructures. So now we are don't using wood for aircraft structures. In early days, we using wood for aircraft structure, but now we are mostly using steel, aluminum alloy, titanium alloy, and fiber reinforced composite are used to construct aerostructures. Aluminum alloy is the most used material for aircraft structures construction, but the main disadvantage is that aluminum alloys have different grades with different properties. You know about some aluminum alloys, duralumin, or some aluminum alloys are have a different properties compared to other materials. In some steel alloys have a same properties, but aluminum alloy is totally different with each other compared to another alloy material. But nowadays we are using aluminum alloy is the most part of aircraft because it's compared to steel, it's have a low weight and high strength. Corrosion resistance is the one of the important properties in aerostructure, but compared to pure aluminum, aluminum alloy has poor corrosion resistant. So you know about that corrosion resistance is very important because we are flying through the clouds and water vapor atmosphere. So the aircraft material easily get a corroded. So we are considered to the corrosion resistant as a main important property in aerostructure. But compared to aluminum, aluminum alloy has poor corrosive resistance. So we are think about the most advanced material like composites because aluminum alloy have a low corrosion resistance. So this is on aircraft, the Mikoyan Gurvich MiG-25 aircraft is made up for military purpose, and the whole structure are made of steel as they can reach up to Mach 3. So this whole aircraft fully made up of steel. It's like a stainless steel or anything using this aircraft. This can reach up to Mach 3. That time it's easily get a over temperature because of increasing of speed of flight. It's due to the friction. It's easily get a high temperature. Due to high Mach number, temperatures over the aircraft structure is up to 300 degrees Celsius. So why we are using steel alloy, nickel steel alloy. For this reason, an iron nickel steel alloy is used in the aircraft structure. As aluminum alloys are not suitable for high temperature application, so we are using aluminum alloys in normal aircraft like commercial flight, commercial jets only using. In fighter jets, are mostly using the steel alloys. Even though steel provides better performance compared to aluminum, you know about steel have a more dense and density power compared to aluminum, so it's have a more strength compared to aluminum, but it have high specific weight. It is not prepared for aircraft structure construction. So if we using steel for normal commercial flight, it's the flight are overloaded and overweight, and it's affected the economical of flight. So most probably every consumer or passengers using uh, want to the affordable price for flight. So it's mostly affected the economic of flight using steel because the steel is also expensive compared to aluminum. So not prepared for aircraft structure construction. However, for highly stressed condition, steel is used because of its high ultimate strength. So we are not overall neglect the steel. Some scenario we are using stainless steel or some steel alloys for aircraft because it's have a highly stressed condition. It's have a Young's modulus or Young's modulus. So you using this material in undercarriage, surface tracks, fasteners, wing and tail to fuselage attachment. Steel is most preferred. Some rivet materials also using in steels. In hypersonic rockets, stainless steels are used which resist kinetic heating. So hypersonic rocket is moving through the Mach number 5 or above Mach 5. So that time the frictions are over. The frictions gives a drag frictions and the kinetic frictions are giving a over temperature in the missiles or rockets. So we are using stainless steel to withstand that temperature during flight. So we choosing composite material for build. Then this is the major of steel and aluminum alloy, but we have one another option that's called composite materials. It's have a both positive properties in the same material. So we choosing composite materials for building and aerostructures because the steels are only using is like military standard flights like fighter jets and hypersonic rockets, and aluminum structures are using in commercial flights. But composite materials are using for both like commercial flights and military aircraft fly also. So titanium, you know about titanium. Titanium is an expensive material, but it's have a high thermal resistance. So its melting point is high, so it's easily withstand the more temperature. In spy aircraft, structures are made with titanium material, thereby increasing the cost. The main advantage of titanium is high strength to weight and good corrosive resistance and better creep properties also. Normally, titanium material will be used only for special purpose such as a turbine blade and spy aircraft. Because spy aircraft is for the military purpose only. So we are using titanium for this type of aircrafts only. But it's very high expensive. So we are ignore this material in most of commercial flights. And in case some like turbine plates or some important places using this material for manufacturing. So this is the major criteria of the last slides are explained the major criteria of material selection. But now we are sharing up the some methods of selection in material. So first one is as-based methods of material selection. Okay. The materials are selected by some important methods. The first one is Ashby's method. Michael F. Ashby is a British metallurgical engineer. He make a standards for material. So Ashby in the 1980s developed the selection of materials for mechanical design by deriving material indices. So he doing some research and project and derive the whole material standards for whole material property standards for material selection. This is used for like a guide for engineers and still because it's based on British standards. Some Americans using American standards also. It's based on full of British standards. This material indices are derived based on the performance criteria of material given mechanical design. So this is it's a performance based criteria. Okay. So utilizing as-based chart is a common method for choosing the appropriate material. So he derived one chart for as-based chart. Uh, I I can explain the chart also in the next slides. First three different sets of variable are identified. Material variables are inherent, density, modulus, yield stress, and many others. So it's mainly focused on density of material and Young's modulus of material and yield strength of materials. So in this method, a pair of material properties plotted against each other. So is using the one graph like y direction is explains the yield strength and x direction is the density of material. So we can took the two material and compare to one to each other and plot the graph in in this material. Also, a database different classes of material is plotted as ellipse showing the range of values for the respective material properties. So this materials are using ellipse shape for showing the material property. So this is the as-based methods graph. So now you see the foam. First, it's a y direction and it's a x direction. X direction is explain the density of material. Y direction is explain the Young's modulus of the material. Young's modulus is already you know about. It's a ratio of stress and strain, because the one material have a high Young's modulus, it's have more stress strain resistance. So it's a basic value of this graph. So first one is foam. Foam, you know, it's a very soft material, so it's have a low Young's modulus and low density. And natural materials, elastomers have high density but low Young's modulus. So we are using natural materials and polymers also, and some scenario for some mechanical materials. In this mechanical materials, it's have a 1 Young's modulus and average 1000 kilogram per meter cube density. But our aircraft industry and aerospace industry mainly used metals, composites, and ceramics. Because of due to this graph, according to this graph, it's have a more density and more Young's modulus. But compared to ceramic and metal, composites have a low density compared to other material and high Young's modulus. So low density is equal to the low weight. So metals and ceramics is more weight compared to composites. So it's an as-based method. So he decided to separate the material based on density and Young's modulus. So another method is decision making method. In the case of selecting material, decision making methods are primarily based on multiple criteria decision making. Okay, simply you can understand this. You have a same specified material, you have a two material, but it's the choice is yours. You can choose any one material because the two materials are apply for the scenario or any part, but you can choose any one, but the choice is yours. So decision is yours. You can using your experience and some property criteria, you can choose any one for this material, but the stress level and specification of material is same. So you can choose any one. That's your opinion also. So this method is called as a decision making method. So it's divided into two types. They are classified into multiple attribute decision making and multiple objective decision making. So multiple attribute decision making takes a finite number of alternative and operates based on ranking and choosing different alternatives that are available for a problem. So you have one problem, you have the finite numbers and you know about the problem, and you have a alternative different material. So you can choose any one from your own knowledge. So it's called decision making method. This method used for a case for finite numbers of alternative, such as elimination the choice of expressing reality. So you can eliminate your unwanted material. So the another method is knowledge based quantitative method. So knowledge based selection is an extension of as based method, because as based derive the properties and the standards for material selection. So if you have an engineer, you can learn about the as based method and you have a separate knowledge, you know, and you can choose some material for your own knowledge and the properties of as based methods also. So we are called this selection material is an extension of as based method. A knowledge based system used knowledge of a given problem and logic to arrive a solution for help making decision. A KBS, as defined as Mayas et al., is a computerized system that uses knowledge about some domain to arrive the solution of problem. If you have a problem of material selection, you put some input in a computer system for analyzing the material selection, and you have a standard of as-based method So this knowledge and your knowledge and computer analyzing give the best result to the material selection. The solution is essentially the same that conclude the person knowledgeable about the domain of the problem when confronted with the same problem. The use of KBS for material selection was reported for selecting materials of polymeric based composites. So this material mostly using for polymeric based composites. The method of quantitatively selecting materials has been tried for various cases, and it can be considered as an extension to an as-based method of material selection. So overview of material selection. So finally, the material selection is mainly aerospace applications such as based on stress, temperature, environmental conditions, moisture, airflow, radiation, and maintenance are essential. Different grades, aluminum alloys and special alloys, their application and the field, defense, sonic, supersonic, and aerospace have been discussed in their chapter. So some aircraft scenario, the aircraft is subsonic or supersonic. There's that criteria also affect the selection of material. Okay, so overall we are thinking about the stress, temperature, and environmental condition, moisture in material selection. So now we see about the properties of material, like material properties in aerospace components. Material properties. Material selection for any application should concentrate on physical, mechanical, fatigue, and grip properties. So mechanical properties very important compared to another properties which offer better load carrying capacity and stiff to the structural design. So definitely we choose a one material. This is definitely offers better load carrying capacity and stiffness to the structural designs. Okay, stiffness is very important. We are using monocoque or coque, semi-coque method shape of fuselage. So it's we have a more stiffness compared to other shapes like a square or a rectangular shape. In aerospace application, aerospace component should have a damage tolerance under both static and dynamic load. So in aircraft we have a static load and dynamic load. So it's flight during flight the aircraft facing the more dynamic loads also. So the aircraft material definitely have a damage tolerance. To achieve that, existing conventional materials such as steel and pure aluminum have to be developed for advanced aviation. So we are using steel and aluminum alloy for advanced aviation, and nowadays we are more developed for composite materials also. The development of new alloys should enhance the resistance to crack growth, environmental damage, and creep strain and high temperature yield stress. So if we develop the new materials and new technology in material science, it's also increase the resistance to crack growth and environment damage also. So nearly all mechanical design involves the selection of material based on their elastic properties in relation to other properties such as temperature, strength, or thermal expansion coefficient. Ultimate strength and yield strength are important for aerospace application. In recent years, development in the material field has enhanced the material properties which are used for aerospace application. Compared to other materials like steel alloy or aluminum alloy, composite material have a more ultimate strength and yield strength compared to other materials. So we are most using this components materials for aerospace components. Okay. The another one is thermal properties. In aerospace, and thermal properties of materials are one of the main criteria, as a component should perform well in the cold and at elevated temperature. In normal commercial flights, flying to the subsonic or sonic level only, so it's have enough temperature, so no temperature affection compared to military aircraft. But that was very important criteria in aircraft for thermal properties. So thermal property is very important in aircraft. The selection of material based on thermal property depends on operating height. So altitude is a very play a major role for this thermal properties. In high altitude we have a low pressure and low temperature. it's a cold stage. It's easily form a ice icing. So it's affect the material, and any shrinkage or easily crack propagation. So scientists using the aluminum matrix like lithium in the aluminum matrix in composites enhance the low temperature properties and exhibit the superior strength toughness combination, lower density and higher stiffness, which reduce the weight by 4% compared to conventional aluminum alloy. Compared to the one aluminum alloy, we are using lithium and aluminum matrix like a composite material, so it enhances the low temperature property. So a thermal properties, low temperature properties also important in this scenario and exhibit the superior strength, toughness combination, lower density and higher stiffness. So it's 4% compared to conventional aluminum alloy. Economics. So it's on another important criteria for economics. Cost is a basic reality to consider while choosing materials for a specific plan for most items, since there is seriously rivalry in the market. So end of the day, consumer or passengers are think about the price range of flight tickets, and another one the airline companies are think about the cost of flight. So they are purchasing a new flight like Boeing or Airbus. They are mainly consider the cost of flight because it's affect of the passengers tickets also. So cost is a basic criteria of or material selection or manufacturing of flight or any vehicle. So it's a major role. They play the major role in engineering manufacturers. So it has been observed that large portion of metal and other significant materials have been supplanted by plastic in the majority of process. For example, automotive and aerospace components, we are using some plastic material for reducing of cost. The cost of the material, and in addition the cost of preparing the material into the recruit from must be considered. So cost is must be considered in the recruit of material. So that is our Boeing aircraft. So we using composite material in this aircraft for a reason: high strength to weight ratio, low density with high tensile strength. So the material have a high tensile strength and low density. So low density give a less weight, high creep strength, high tensile strength, and elevated temperature. In aircraft going through the air, that time he facing he's facing some friction, and it's made a temperature, elevated temperature. That time it's have high strength, tensile strength compared to other material aircraft, high toughness also compared to steel. So this is a Boeing 777. So it's a composite structure of the aircraft. This white portion is made up of aluminum alloy something. So this red portion is a toughened graphite. So it's have a more strength compared to other materials because this portion is easily get over temperature, elevated temperature. And the green is made up of graphite composite, and pink is a hybrid. The blue is fiberglass made up of fiberglasses. This is the aluminum alloy aircraft. So some products and some parts components are made up of composite materials only. So Boeing 787, this aircraft fully made up of composite materials because maximum made up of composite material. The 50% of aircraft like the blue shades are denote the composite materials. The 50% of aircraft are made up of composite materials like this. So the composite materials are more useful compared to other materials. So we are using Boeing 787 using the composite material. The composite material called as a carbon laminate material, and another the light blue was a carbon sandwich. It's also composite materials as a carbon sandwich. So totally 50% of parts of a composite aircraft made up of composites, and is fiber, aluminum, and aluminum. So totally aluminum are using 20%, and titanium using 15%. Okay, where is the titanium are using? The nose cone of aircraft using titanium, because it's easily get over temperature. So some material easily melted at this temperature point, but titanium have a or high melting point. So we are using titanium in the nose cone places, and still using 10%, like joining of material, like the jet engine is joined using the steel have a high strength but a high weight also. So we are using steel material as a joining material. So other material like plastics or polyesters, their foams like 5% of materials using like a interior design of aircraft. So these five composites are using this materials are using this aircraft, and some other important alloys are using also, like aluminum alloy, titanium alloy, steel alloys are using this aircraft also. So this is a Tejas hypersonic aircraft. It's a Tejas supersonic aircraft. So it's designed by HAL. So it's a basic composites of this aircraft. This is a 40% of using main material, and steels are using 4.5. CFC is a glass fiber composite material. You know about that glass fiber composite material, and steels are using 4.5%. Titanium alloys for 5%, because it's the main point of temperature point. So titanium alloys are using that. So it's a yellow point. It's called as a Kevlar composite. Kevlar is the most strength composite compared to some other composite materials. So the nose cone are made up of Kevlar composites. So other materials are using 2.5%. Aluminum alloys using for 40%. Like main important bodies are using creating by aluminum alloys. So components are made up of composite material is nose, wing, upper surface, and leading edge exist nozzle. So this part is easily get a high temperature and easily melted in this scenario in other materials. So we are using composite material on these places like nozzles and leading edges and surface of a wing. So composite used in Martian suit. So this the suits are made up of composites to prevent deadly cosmic rays and gravity that is just 38% of the Earth, to maintain the pressure in atmosphere pressure inside the suit. So that's